Okay. So solve the triangles with the following information. Alpha equals 39.6 degrees. Side C equals 18.4, and A equals 3.7. So sine of 39.6 over, what is that, 3.7, is equal to sine
Sine
of,
18.4, right?
no, sine of gamma, which I don't know where, I'll just do big C for that. Sine of big C, copyright. Yeah. Stop doing that. Over 18.4. I don't know exactly what she wants because it just says solve the triangles with the following information.
So you're going to need to find all three sides and all angles.
Yeah, probably. Presumably. Oh, so naturally. Okay.
So we have side A is 3.7. So this one, we have two sides and an angle, right?
Yeah.
Okay, that's what I was thinking.
So what does it say solve? Are we just by what are we solving? Just the rest of the angles?
Yeah, and the sides. Oh gosh.
I'm gonna go get my notebook so I can help do some of this stuff.
Sure.
Works for me.
I feel like there's always just so much crap to do. Like there's a to-do list that's just never ending.
So true.
Like those moments when you feel like you've got everything under control, life just suddenly decides to take a dump on you. All right, so is C the hypotenuse or no?
Not necessarily, but mostly, usually.
It's super annoying if it like because we can't tell.
So I solved the second one.
The second one? This one?
Yeah, that one, because I figured somebody else was working on the other one already. So for the second one, the three sides are A is 40.7,
Oops.
B is 52.5,
52.5.
and then C is 84.5, I guess, if we're running.
These are the sides or the angles.
That's the sides.
Okay, I'll put those in lowercase.
Yeah, and then the angles I have 21.7, well, 21.8 degrees for A. And then B is 28.6. And then C is 129.61.
And C is 29.61.
Yeah. And I just did the sign thing that you did above there for all those answers. So if anybody was wondering what I did.
Yeah. Oh, gosh.
You all right, Chris?
No, it was just work yesterday. It was absolutely insane. So, you know.
Last night I did 3 accounting assignments and I got lower than a 40 on all of them.
That's always a good sign.
My letter grade only went down by 1 percentage point.
I hate that. I hate when assignments, you do 50 assignments and they count for like 2% of your grade. And then one test is worth 90%.
Yeah. Or when like they don't teach the assignment. I don't know. That bothers me.
Yeah.
Okay, so let me do this piece real quick. Well, that's weird.
What? Are you having trouble calculating the first one? Because I am too.
You what?
Are you having trouble calculating the first one?
Yeah, because it doesn't add up.
It doesn't. It's not adding up for me either.
Unless it's like a super, super skinny triangle.
No, there's also, you know how we have Symbol Lab and stuff for checking algebraic functions?
Uh-huh.
There's a website called www.triangle-calculator.com that will do this for you, just to check your answer. And it's saying, I don't know how to compute this triangle. So that's an indicator that there's something messed up with those.
What does it give us? So we have 2 sides and an angle?
Yeah.
So I got.
Would you use cosine with that then instead of sine?
No, you'd use tangent.
Because you have sides, isn't it? There's something.
Well,
you'd have to use cosine.
I use tangent at least.
Oh, do you?
Yeah. So the 3.7. Obviously, that's not the hypotenuse, so we can just assume that we can use tangent with that. And I did tangent. Or I did 3. What did I do? I didn't write it down. I did like 3.7 tangent 39.6, and I got 3.1.
That would sound about right. Well,
that's
a really weird, because if C is the hypotenuse, that's a weird looking.
I know, so that I don't think that's correct, and so I
wonder if they messed up the decimal point. I wonder if it was supposed to be 1.84.
Well, I could try it on that calculator real quick.
And then I assumed that C was the hypotenuse, and I did it the other way, and I just did the Pythagorean theorem, and I did A squared plus B squared equals C squared, so A squared.
That worked.
You what?
Oh no, I did what he said and did 1.84 instead of 1.84.
Or
that worked. Yeah, 1.84 instead of 18.4, and that works.
It works. What's the answer?
The sides are A equals 3.7, B equals 4.927, and C equals 1.84. And the angles are 39. A alpha is 39.6, Beta is 121.9 and gamma is 18.4
121.9.
for beta. Yeah,
How can you have a
That's
angle
that's the angle.
that's over a right angle?
it's an obtuse scaling triangle.
It's obtuse angles.
That's dumb. Okay. I'll take it.
So we're gonna call that as this is the one. The what?
Yeah, I'll take the constructive criticism on that one. The loss.
There ain't no loss here. Only trying to finish.
Oh yeah, sorry I didn't show you the last one.
Oh no, you're good.
Gamma equals 32.7, C equals 28.6, and B equals 37.5. C equals 4.
So is C our hypotenuse then?
I would presume.
Or it would be our hypotenuse.
C is generally the hypotenuse.
So we're trying to find a really small side then?
Yeah.
Yeah.
Not necessarily, because that angle Y is pretty big, right?
Well, that's gamma, but yes.
Well, yeah.
Yeah. It's a really funky triangle.
Yeah, it freaking sucks.
I love it. It's fantastic. So would you use cosine on, I don't know how to find A. Would you just use sine again? Or would you use,
To find A,
yeah, because that's the side that we're looking for. And then if you find A, you can find all
I
the
think-
others.
I think you have to find what. Oh, well, it's A squared plus B squared equals C squared. It's just simple Pythagorean theorem because you have these two sides right here.
Yeah. So if we find that, can't we find the angle really quickly?
I presume. Oh, angle A. No, you said side. Did you say side or angle?
I said side because you can find all three sides.
Yeah.
But I don't know. It could be.
Who knows? So do you want to call it quits on this one and move on to the next one?
Yeah, that looks good to me.
Yeah.
How many more of these do we have before the quiz?
Just one. Just this one.
Okay.
Let's see. A friend offers to take you on a plane ride from Rexburg, Idaho, to pick up another friend in Idaho Falls, Idaho. Then go to Jackson Hole, Wyoming, for lunch
Wow.
before.
He just freaking drove.
Yeah, no kidding. Why would you go all the way to Jackson Hole, Wyoming, to get lunch before going back to Rexburg?
Well, I don't know why the guy would have to fly from Rexburg to go to Idaho Falls. Why would the guy not just drive from Idaho Falls and meet the guy in Rexburg and then fly?
Who knows? You leave Rexburg on a bearing of south 13 degrees west. When you leave Idaho Falls, you head due east towards Jackson Hole. It is 91 miles from Idaho Falls to Jackson Hole. I guess
Where did we eat in Jackson Hole?
after having a delicious meal at Jackson Hole, we return to a trip home on a bearing of 290. Oh, that's supposed to be over here. Oops. And this should be right there. Yeah.
We know that angle would be.
What has it told us? Yeah, so it wants to know what the length of all these three sides are. Bing, bing, bing.
Doesn't care about the angles. It cares about the sides, right?
Yeah, but you're going to need to find the angles to know the sides. So I guess we don't really need to know.
Is that so that 290 is on the outside, right?
Yeah.
And is that 13 on the inside or on the outside?
It's on the outside, but we can use the parallel line to know that, it's 180 minus
13.
Yeah.
And that one is, the other one would have to be
290 minus 180, I think. No.
360, right? No, yeah, you're right, 180.
That makes no sense, but
Wait, so what are you doing? You're just taking 290 and then subtracting all three of those to try and find out what the actual inside angles are?
Well, if you extend this triangle out as a parallel line, we know that the parallel line, all the angles on the parallel line have to equal to 180. So we're trying to find out what this angle is on side the triangle because we know what the outside angle is.
Oh.
If I'm not
I'd
mistaken.
probably say like 60.
Well, 290 doesn't make any sense.
No, it doesn't. That's what I'm trying.
Unless it's like 290 around the whole thing. So then you do 360 minus 290. Like pretend that little blue circle, like that blue little semicircle created an entire circle.
Yeah. Oh, just kidding.
Yeah, like that. And 290 was the entire outside. That would make sense.
That's probably what it is. Yeah. You're making it a whole 360-degree turnaround.
Yeah, so then we just do 360 minus 290, which would be 70.
70 degrees, yeah, 70 degrees. Good way. The question is now, what is this supposed to be then? Because no way this angle right here could be 167, but maybe it could be, actually. Yeah, that could be. Yeah, but
167?
yeah.
Well, no, because the inside angles of a triangle are supposed to add up to 180, right? It doesn't matter what kind of triangle or how big the biggest.
Why would that one be so big, though? Because, that's the outside side, right?
Yeah, it seems way too big to me.
It seems way too big, too.
Hold on. I'm gonna do something. So wouldn't hold on.
So this says C plus D equals 180, angles on a straight line. So if we rearrange, subtract C from both sides, and then we get A plus B equals 180 minus C. And D equals 180 minus C. The exterior angle is equal to the sum of the two opposite interior angles.
Say what?
Supplementary angles. Now, how Z and W make together make a straight line, that's 180 degrees, so we make an equation. Now I rewrite the second equation as this and substitute that for Z in the first equation. Oh, there's a theorem. It says it's called the exterior angle theorem, which says the measure of an exterior angle of a triangle equals the sum of the measure of the two remote inner angles, or X and Y of the triangle. So if we screen share. So we have our exterior angles. Oh, they did an equation. Problem is they have two interior angles. And the two. 30, find X. Remember, exterior equals the sum of the two interior angles. Given the exterior angle of 110, we equate 110 to 2x plus 30
my
plus 50
goodness.
for X.
Could that be why I messed up?
Are you looking at my screen, or can I stop sharing?
You can stop sharing.
So they say to draw a straight line, and then the two interior angles should equal. So if you draw a straight line from the 13 degree down to the bottom right, those two interior angles have to equal 13. They have to add up to 13, which would be a lot of options.
True enough.
But I don't understand how they'd equal 290. What two inner angles could equal 290 without going over 280 or 180?
Well, so they're talking about bearings, and bearings would have to do with like direction and on a compass. So like maybe if we were able to set up like, so the first one, Rexburg, where 13 is, that's right, because they're going southwest. Anybody have a compass?
Wait a minute. Wait a minute.
Waiting. You've got my attention.
This might be backwards. Huh.
Here we go. Here's a compass, guys. I found one.
Another way to calculate the exterior angle of a triangle is to subtract the angle of the vertex of interest from 180.
Okay, this question literally doesn't make any sense. Because bearing 13 is northeast.
They faked it. They faked it.
They're not flying.
You're a phony.
Maybe that makes more sense.
Oh, so if we think of the sum of the outside angles, it'd have to equal 360, right?
Yes.
So couldn't we just do the exterior angle of 290 plus the exterior angle of 13? And then that would give us the exterior angle of the last one, right?
Presumably. You leave Rexburg on a bearing of southwest. Head due east to Jackson Hole. Uh-huh. What the... Oh, that's right. That's why that is. No, that still makes no sense. Southwest, that's right. You leave Idaho Falls and you head due east, so straight east towards Jackson Hole. This is 91 miles from Idaho Falls to Jackson Hole. And this is just so you return home on a bearing of 290 degrees. Maybe. Maybe that's a little bit more accurate. Return home on a bearing of 290 degrees. Oh. Well, we have a sine. We can use the sine function right here now. Sine ratio. So we have a ratio right there.
Wouldn't that bottom right corner be 90 degrees?
No, this triangle is not to scale.
Okay.
So we have a ratio right here, I just realized, and we can use that to find this ratio. So sine of 13, correct me if I'm wrong, but I think at least the angles in the measurements are all in the correct spot. Yeah. Does that seem right? And then we could have x equals... Let me think, what was it again? Sine of 70 times 13 times 19, excuse me. 19, and then divide the whole thing by sine of 13. Correct? I hope. Maybe. And we'll call it h because it's the hypotenuse, actually. Da-da-da. H equals sine of 70 times 19 divided by sine of 13. Yeah, that makes sense. 78.34. 7. 79.37. 79.37. So the hypotenuse, no, that makes no sense. But this isn't the scale, so that could be true. So I got the hypotenuse of 79.37, or this length is 79.37.
How is this 79.37 if the others, if a shorter side, which isn't the hypotenuse, is 91?
Again, this triangle is not to scale, so I'm not sure that's actually.
Well, either way, wouldn't the hypotenuse be the 91?
I'm not sure.
Because generally a hypotenuse is the longest side. It's the side that.
Sure. Oh my gosh. Let me try that again, maybe.
This would be much easier if we, I don't know, saw a video of someone doing this and explaining how to do it.
No. That'd be too easy.
No. Maybe it's 290 that I'm supposed to put in for there. Could try that. That goes how that fares. No, that'll be smaller, I think. Yeah, that'll be smaller. I thought so. I can't think of any other way to do this though. That's the problem.
The only.
That would be 13 actually.
So we know two of the angles, so can't we just like
Plug it in.
add those up and subtract from 180 to get the last angle?
So I would think that's what I've been doing. But how did we get the 70?
So the 70, so 290, we're thinking that 290, because it's impossible for a triangle to have a degree of 290.
On the inside anyway.
Yeah, on the inside. So we're thinking that the 290 was on the outside. Or
then you just added it up to 360?
Yeah, or we could, honestly, I'm almost thinking that we're doing it all wrong and that we're supposed to figure it out from an actual compass, like, because the compass has degrees all the way around, and it says that they were at 13 and they went to 290, and we're trying to figure out this last bottom angle. But that's too hard. I don't want to do that.
How about we move on to the quiz, see if the quiz helps us figure this one out, and then we'll come back to it at the end.
Are we going to be graded on this one, or we just got to figure out?
No, that one's just participation.
We participated.
The group quiz.
So I'm thinking maybe the group quiz will even help us figure it out, you know?
Explain why the expected response arc sine of -1/2 equals -pi6 and not 11 pi 6. Okay.
Well, the secret here is that it actually does equal that.
Sine of 1/2. Sine negative. Oops. How would it? Why? How would it?
So we're trying to find the what now?
We're trying to find. We know that this equals -pi6. We're trying to find out why it does not equal that.
What is the arc sine of -1/2?
Yeah, why does it equal this -pi6 and not 11 pi 6? Good question.
Because it doesn't want to.
Because math. I don't get why somebody would think that. That's why I'm so confused.
One person's like, "Oh, this is a great question."
Because the unit circle says so? Honestly.
Why would it not equal -pi6?
Yeah.
Because it's in the wrong coordinate plane? Because negative...
Well, yeah, 11 pi 6 is not... That's one thing that would trip you off, that 11 pi 6 is not negative.
Well, I mean, it kind of is negative.
What do you mean?
The coordinates on it, the sine and cosine. Cosine is -1/2. Or no, sine is -1/2. But that would, if it were arc sine 1/2, yes, the answer would be 11 pi 6. But since it's a negative, the two negatives cancel out, I guess. So it would have to be pi 6.
Just 1/2. 11 pi 6 would be the end. It is either 1/2, not 1/2. So the answer is negative pi 6. Phew. Done. Stop that. Okay. The sun is far enough away from an object in a shadow will make a triangle that is similar. There's a similar triangle with another object and its shadow. In geometry, you learn that if two shapes are similar, one is an enlargement of the other. This means that two shapes will have the same angles and their sides will be in the same proportion. What information do you need to calculate the height of the Rick's building in feet and inches without actually measuring the building? After you list the information needed, set up the problem as if you're going to solve it, and draw a picture and set up a ratio. Oh, we didn't have to solve it. Woohoo! So it's just asking us what information do we need to complete this problem. I think you could measure.
Sorry, I'm back. Okay, and you make sure the one is an enlargement there. This means that the two shapes will have the same angles and their sides will be the same proportion. More information will be needed to calculate the heights of the Rick's building, feet and inches, without actually measuring the building. As you list the information needed, set up the problem as if you were going to solve it. Draw and label a picture and set up a ratio.
So I just looked up and we had the reasoning on number 1 wrong.
What was the reasoning?
So the reasoning is if it were going to be 11 pi 6, that's like almost all the way around the circle. But because it's a like arc sine 1/2 and like arc sine 1/2 is pi over 6 and arc sine negative 1/2 is negative pi over 6, because all you're doing is like flipping it over the x-axis. So the angle is the same. Like you're still going the same distance down, which would be sine. You're not going all the way around the circle. Does that make sense?
Oh, yeah.
Because when you negate it, all you're doing is flipping it over the x-axis. The coordinates stay the same. They're just negative. Tricky little question. Have you guys been getting emails from Sister Hess?
Yeah.
You? What'd she say?
She's just like checking up on everybody.
Nice.
Not it's like about how I don't feel like I have time to do anything. It's a lot of work. That sort of stuff.
Way to figure that out. I'm impressed.
Thanks.
There we go.
Love you.
Oh,
Are you going shopping? Have fun.
I thought you were talking to me.
Love you too, man.
Well, you guys know.
Oh, gosh. Okay, so hypothetically, what information would you like to have? So I did this. I took a picture of Google Images, obviously. And there's actually conveniently a shadow right there. I think you would want to know the height of this lamppost right here, I'm guessing. And the angle. So we want the height of the lamp post. Whew. Angle of the roof to height of lamppost.
Wait, why are you doing the height of the lamppost?
Don't you want to know this height right here? Maybe not. Angle.
What I'd get is I'd get the, because you know one's going to be a 90-degree angle. So you have the 90-degree angle from the building to the ground. And then I would get the measurement of the bottom triangle from how far out you walked. And then that would get you your two things there.
Base.
And then you can find something else.
Basis angle. I was thinking the angle of the roof to the bottom.
I'd just find the architectural plans, find out how high the building is.
Do we not have a tape measure with us?
I know, like for real.
Yeah, watch, yeah.
And then I'd use the new high-tech laser pointer that measures distance, and I just point it at the top of the building from where I'm standing to find the hypotenuse.
Honestly. So you want the angle of the roof to the distance that you've walked, so that angle right there. The base of the smaller triangle, and then what else do you think we need?
Well, you have to have at least 3 things to solve the whole triangle. And so we need to know it needs either 2 sides in an angle or 2 angles in a side.
And then we know that that's 90 degrees, I guess. So that's good.
So we have the 90 degrees. So I'd put that down in there as well. I put that down as that we have the 90-degree angle from the building to the ground.
Okay, then it says I also have to make up some phony stuff. Set up the problem as if you're going to solve it.
So we just have to write an equation, essentially.
Pretty much. And we have to set up the freaking thing.
So do we have 3? So yeah. So we have the base of the small triangle from how far out you walked. We have the 90-degree angle. And then based upon the 90-degree angle, so we only need one more, right? We just need one more angle or one more side, but I don't know how you'd figure out the next angle or side.
Oh, gosh. Why is this giving me such crap? It was working just perfectly before.
Oh, halfway there. Whoa.
Munching on a pear. You
Never
guys
heard that part, but I
you guys-
like it.
those memes a while ago where they were just finishing that song?
Yeah, have you seen the Nickelback one where he's like, "Look at this graph," and he's just holding up a graph instead of a photograph? Is that the same thing you're talking about? Look at this graph.
It's a great song. I don't know why people hate it so much.
Freaking A, man.
Yeah, I don't either. I liked it.
We're talking about Nickelback while Chris is just like struggling over there.
I know. Sorry. I can help now.
I mean, that's cool and all, but it's just stupid. Works so perfectly.
Stupid's not a nice word.
Were you talking about Nickelback or the equation?
We're talking about, well, both of them. But just kidding.
Whoa.
Just kidding.
Mind blown.
Okay.
Your noises are just so funny because we can't see like your reactions or your facial expressions or anything like that. So like we're literally, it's like I'm watching a YouTube video of someone like trying to figure out this equation. Sorry, it's not funny because I don't know how to do it either.
Okay, so yesterday, if you didn't know, at Papa Murphy's, Halloween is the worst day to work ever because everybody wants freaking pizza. So we did freaking 500 pizzas on Halloween night. It was crazy.
500 pizzas?
Yeah. And then today.
So you work at Papa Murphy's?
Yeah. So
Which
today was
Papa?
the one here in Washington, in Renton Highlands.
In Washington?
Mm-hmm.
Not in Rexburg.
No. But I might hit up that place sometime. Anyway.
Don't do it. It's not worth it.
It's not worth it.
No.
It's like gross.
No,
So
I mean,
here's how they said to measure the height of a tree, since we'll get back on topic now.
oh, I'm
It
sorry.
says all you need, let's see. Says fold the piece of paper in half so it forms a triangle. Hold one corner so it forms a triangle with the opposite side, then cut off the extra paper above the triangle. You should be left with the triangle you need. It'll have one, oh, that's why, because we have 90. So if this is a perfect right triangle, it says the triangle will have one 90-degree angle and two 45-degree angles. So if we make both angles up there 45 degrees, then we can find the other three sides, and that'll give us the height.
Well, how do we know that they're supposed to be? How do we know it's a perfect right triangle?
Because if you do it right, it'll be a perfect right triangle.
Yeah, because
Because I wouldn't measure the Ricks building as long as it wasn't a 45-degree angle.
Okay.
Well, and I mean, it says it, this literally says to fold a piece of paper, hold it up, look at it, and make sure that you walk away 1 to 1.5 times the length of the tree, the height of the tree. And then it says you'll be looking at one side called the hypotenuse of the triangle, and move back from the tree until you can see the sight of the top of the tree at the tip of the triangle. And then you've got your triangle there, and you mark it.
What?
The tangent of a 45-degree angle equals 1. The equation can be simplified to this. The height of the tree divided by the distance of the tree equals 1. You multiply each side by the distance from the tree, and you get height of the tree equals the distance from the tree.
The fuck? Okay. Just gotta breathe here.
So that makes sense, though. If it's a perfect 45-degree angle, you have all three angles, or a perfect right triangle, which is
It's
what I would
45.
say it would be. Then you have 45-degree angles. And then you can use all three angles to find the height and the side.
Yeah, because you could make it so it's 45, 45, 90.
Yeah. Because I don't think you're going to be like kneeling down and making that angle any smaller where you're standing,
Really?
At least I wouldn't be.
Freak. Anyway.
Living on a prayer, take my hand. We'll make it, I swear.
Well,
That's a song we used to sing when we were halfway through our mission.
Really?
Mm-hmm.
It's always nice. That's nice.
Okay, that's 45. That's 45.
it sounds like this that I wonder what Jerem is doing at this moment.
Sleeping.
Smartest decision he's ever made.
He's living on a prayer.
Living on a prayer, he'll graduate.
Oh,
He dropped out like completely though, didn't he?
I don't know.
that I have never seen a more perfect connection, like a more perfect angle sign. Like that was impressive. That was just like completely guess and check, and let's just throw it in there and it fits.
Okay, so what else do we need to know?
Well, then you'd have the base. So you'd have the base of the triangle, and you have all three triangles. So you already have 4 of your equations. So you pretty much got it.
So what do
So
we
we just got to write the equation now.
But what do you want to make up as the base of this small triangle? Or do we just want to know? Yeah, we want to.
Well, no, we just got to write an equation. So you in the equation, you literally just put base of the triangle.
Oh, so what would you want the equation to be?
You could do angles. You do your sine one. That'd be a possibility. Because you have sine angle A.
Sine of.
Let me see.
Halfway there. Well, I'd say that we want the lamppost because.
Oh, so it's the sine rule. So you have the sine rule, which is A over. Let's see. So you'd have angle A over sine A, which equals angle B over sine B. Well, it's capital B, so that's angles. So you'd have side A over sine angle A.
Sine of A. Sine of
Over
A.
no, it's
Over A, lowercase a, is equal to sine of B, capital B, over, not B,
yeah.
not body odor. Stop putting body odor. Seriously. Okay. That's the sine formula. So that's what I was saying before. You want to know the height of this lamppost, because you could do the sine of 45 is to this height as sine of 45 is to this height.
I like it.
And then you.
Well, the sine rule finds your unknown sides. So if we have all three angles, why does it matter?
Just a simpler way to do it. Any way you want to do it.
Well, the sine rule finds your sides.
What sine rule are you talking about?
Your sine rule, because what you do is you do your what they did is they have the side A over the angle sine A, and then that equals B side over the sine of angle B, and then you can find it out by using your angles to figure out which letter you're wanting. And you have the bottom base height or the length, so you already know that one too, so you can do that one. So you'd have that as B, so you'd basically do the base over angle B equals A over the sine of angle A, and that would give you the side of A.
You're saying the base over what?
Your angle B, which would be 45. So sine 45 degrees.
45 degrees.
And
Equals
then that
to.
equals side A
Or A, yeah.
over sine angle A, which would be 45 as well.
Okay, that makes sense.
And then you just solve for A. But I do the base length. That way they know what you're doing.
Base length, and this is side A.
And then you could even find the hypotenuse by doing the same thing. You just do, actually, you know what? I don't think, can you find sine B like that, side A like that? You might have to do instead of side A, put side C and then sine 90 degrees. That way we find the hypotenuse first.
So this would equal the hypotenuse?
That would equal your hypotenuse. And then you can solve with the hypotenuse using the sides, the hypotenuse length, and then, does that make sense?
Mm-hmm. Oh,
so after that, then you do hypotenuse over sine 90 equals A over sine 45.
Hypotenuse over sine of 90. 90 equals what did you say?
Hypotenuse over sine of 90 equals side A.
Side A,
over sine of 45.
And that would get us the height.
Yeah, that'll get you the height.
So let's get this labeled accurately.
But Chris, what's worse, working on Halloween or working on Super Bowl weekend?
Halloween.
Really?
Because at least on the Super Bowl, once the Super Bowl starts, it's dead. Nobody comes in. Halloween's not just like a 1 hour event, so it's like all day.
Yeah, I work at Olive Garden.
Uh-huh.
And I think it's funny because like the busiest days for us are like the least busy days for you and the opposite. So like Halloween, there's like nobody in the restaurant because no one wants to go out to eat.
On Halloween, yeah.
Yeah, but like Mother's Day and graduation, like all of these fancy holidays, Father's Day, Valentine's Day, like these are all stupid busy.
Stupid.
Like 45 hour
busy,
minute,
super busy. No.
stupid busy.
So yep. Okay, so what are we calling side C is my question, so I can label this.
Jimmy.
Your side C is the hypotenuse, I thought.
So why is side C equaling the hypotenuse?
You're using that equation to find your hypotenuse. So you can just put side C or hypotenuse.
Oh.
You know what I mean? You're trying to find C by using that equation. And C is the hypotenuse.
Oh.
So the base length divided by sine 45 is equal to the hypotenuse divided by sine 90.
Yeah. Which equals the hypotenuse. Okay. We're good. Okay, I was just confused for a second. Okay, the dumbest thing though happened yesterday. So we were closing, and it was closing hour. And this guy comes in after closing hour, right as we're locking the door. He's like, can I have a paper towel and some water, please? We're like, okay, sure. And right as we come back, he bolts for the door and he stole the tip jar.
He stole your tip jar?
He stole the tip jar. So dumb.
That is so messed up.
How full was the tip jar?
Had $20 in it.
And then that was for the night?
Yeah, that was for the day. Yeah.
Dang.
Jeez.
Like, who does that?
Somebody is really desperate for $20. That's all I gotta say.
Honestly.
Dang.
Screwed up people, man. Why do you keep doing this dumb crap to me?
So Jason, where do you live?
I live in Rexburg originally, but I'm down in New Mexico right now visiting my in-laws.
Ooh, New Mexico.
What part?
Rio Rancho. It's by Albuquerque.
Okay, I've got family that live in Santa Fe.
Oh, nice.
My dad is going to Bosque del Alpache in like 2 months.
Yeah, that's cool.
Have you been there?
I haven't, unfortunately. I haven't explored New Mexico too much, just where I need to be.
So that's C, and we want to label. Yes.
We're gonna get it together somehow. We're gonna get it together right now.
Don't do that to me.
Sorry. You know what I equate these online videos to?
What?
In high school, did you guys ever have to go to like, or you didn't have to, but the teachers ever say like, all right, Saturday we'll have like an extra credit activity and you'll get into groups and stuff, and it's like totally chill?
No, thank goodness.
Oh. So I had some of those, but they were like extra credits, so I didn't have to go, but I wanted to. And it was like at 8 a.m. on Saturday morning. So like the teacher would usually buy donuts or something, and there would only be like 8 kids that would come in. And you would divide into groups and like 2 or 3 groups, and she would give you a piece of paper that had like a couple of problems on it, and you had to work together as a group to get the problems. But she would walk around like answering questions and like helping you through the problems if you had trouble. I imagine like getting this and not having a teacher in the room to help us out is equal to going to school on Saturdays.
I had a class on BYUI on Saturdays. It was the worst thing I've ever done in my life.
How is that legal?
Because they had because I'm an exercise phys, and they had so many kids that were in the degree, but that they didn't have enough classes or enough space for everybody. And so they said, you don't have to take this, but if you're wanting to take this class this semester, this is the only one that's left. And it's the only reason they opened it. And so I took it because I didn't want to have to wait a whole nother semester to take the class. I don't know how it's legal, but I took a class on Saturday.
Phys major?
What?
Are you still an exercise phys major?
Yeah. Why? You sound nervous.
I'm not nervous. I'm wondering if like that deterred you.
No, it didn't. In hindsight, I probably should have became a biology major, but
I hate biology.
I know, but I'm planning on going to med school, and there's a lot more that they teach you about like MCAT and stuff in biology degree. And so I'm kind of behind on that aspect, but oh well. What do you do?
What do I do?
One of these.
Except for living on a prayer wall.
You kill yourself doing one of these problems. That's what you got to do.
Reach it.
Okay. Oh yeah, and that's 75 feet further down there.
I only know you guys as like my online friends, so like if I were to somehow see you guys in public, I don't know what I would do with myself.
It'd be like weird.
I would like
know him.
They exist.
I know him.
Oops, that's not degrees, that's feet. Oh gosh.
This is the same that we had trouble on the other day, isn't it?
That's what I'm saying. Kill yourself doing this problem, man.
I looked up. Where did it go? It's called an ambiguous triangle. I looked it up because I couldn't figure out how to do it.
All right, so
So it says, when using the law of sines to find an unknown angle, you must watch out for the ambiguous case. This occurs when two different triangles could be created using the given information. So I'm assuming we're still using the ambiguous type thing. So we're given two angles in that little chunk.
Yes.
So you do it the same way. You
see if you're getting the sides and the angle not in between.
God bless.
Thanks.
So this still says to use the law of the sines to figure this out.
Yeah, I mean we can. It's easy enough. So
which is the A, B, C one that we just did.
Do you know where the obtuse angle is in this equation? Right at the opposite end of that 36.5. You know what I'm talking about?
Okay.
I think it looks good. I just leave it like that.
Yeah, I just leave it. I wouldn't even mess with it.
And then I wouldn't even I wouldn't put it back on the picture. Just leave the picture out.
It's not like it's that hard. I mean,
So you see, hold on. Let me just do some funky stuff.
like LSD, you're about to do some funky stuff.
No, don't watch me do the funky stuff. But and that's a right triangle, right? Like that's a right angle.
Yeah.
So we know all of the degrees in this.
Yes. Yeah. Yeah. Mm-hmm.
Mm-hmm.
Let me find the degree for that last one. Plus 90 equals 126.5. 53.5.
Yeah, 53.5.
Is that the last angle? Okay. That. Show all your work.
Including Moon.
Okay.
What?
So wait, on the last equation, you wanted the height of the lamppost, right?
Mm-hmm.
Why did you want that?
Did I put that? Oh, not in the end. In the end, I didn't.
But do you want it now?
Well, there's no lamppost. There's an American flag, but there's no lamppost.
We can create a lamppost though. All you do is just draw a straight line from the obtuse angle up to where it connects, and that creates a 90-degree angle. Does that make sense?
Yeah, but I feel like there's a better way to do this.
What's the equation though? If we wanted to have, if there were a flagpole right there, what would be the equation or the lamppost? Because there's the same geometric principle that angles that are the same angle that are similar.
Well, yeah. I don't know if that would work though.
Why wouldn't it?
Well, I was thinking 36.5 is to the height of the flag, so to speak. The sign. I mean, a sign of 63.5 would be that. And 62.3.5 is to the height of the steeple. But I don't know if that would work.
So sine of 60 or 36.5 is
Divided by
flagpole.
Divided by the height of the flagpole.
Divided by the height of the flagpole.
No, that's not going to work because you need a different. Well, you need what? Yeah, no. To do that, what you're talking about, we need to find this length right here. Because it'd be the height of the temple is to sine of 36.5, as 53.5 is to this length. That ratio would be work. That would be correct.
Oh. That's dumb.
But how do you find that legs? Oh, that's a good question. Oh. Okay. I think I may have something, but let me think. Let me see. 180 minus 47.8, 132. I know I won't actually. Okay. I don't know if this would even help, but
Sir.
yeah, that would work.
What would work?
Because I was thinking you could find the length of this hypotenuse by saying 75 is to the sine of this angle right here, the small angle, as 132.2 is to the hypotenuse.
Yes.
But how did we get that small tiny angle though?
A small tiny angle?
Mm-hmm.
You would just do 180 minus 132.2 minus 36.5.
Yeah. Duh.
There are my participation points.
168.7 minus 168.7. 11.3 is the angle. Measure that tiny, teeny angle.
That makes sense.
Oh boy. These problems are so annoying. .3. Did you guys do the individual quiz yet?
No, I haven't even started on my homework. I'm so far behind.
Oh crap! This homework takes forever. Anyway, focus. Let's focus. Okay. The sine of 11.3 over 75 equals the sine of 132.2. 2 over the hypotenuse.
Snap.
Happened. So the hypotenuse would equal. Well, I can't even think anymore. 2.2 times 75 all over the sine of 11.3. That makes sense. Does that even look right? I hope so.
Wait, why did you put 123.2? It's 132.
Oh, except that. Sine of 132 and then times 75. Sine of 11.3. Two 23.55 H equals 283.55. That makes sense. $283.55. Okay. Yay, we know the hypotenuse. Woohoo.
Can I just copy all that down? Because I don't know how to do this still.
I'm so confused too.
Yeah, go ahead. No copyright.
I wonder what it's called. I don't understand. Like, what is this triangle called? Is it like a right triangle within a right triangle?
I guess. Oh my gosh, we made it. Woohoo. So, because now we can have sine of 90 is to 283 feet as sine of 36.5 is to the height. Bam. Kill him. Kill him with kindness. Kill him with kindness. Kill him. Kill him. Kill him. Sine of 90 degrees. You can use 90 degrees, right?
Yeah.
Mm.
Always.
90 degrees is to 283. 83.55.
I wish there was like a website where you could just like draw your problem in and just be like, help. Help.
That's funny.
One day there will be one. Sine of 36.5 is to H, to the final capital H for height.
Can't we just look up how tall the temple is and then
Well, it's probably not. It's probably not correct. Like, this probably isn't actually solving any problems.
Fortunately. So we have.
So we have to solve the inside parabola or the height?
The inside parabola. What are you talking about?
Not inside parabola, the inside hypotenuse.
That's not inside hypotenuse. We just have to solve the height.
Oh.
Thank goodness. Yeah. What is the height of the Rexburg Temple, including Moroni?
I was just confused because you put H twice.
Oh, this is hypotenuse, little h. Big H means height.
Oh. Freaking H's.
56.5 times 283.55 divided by sine of 90. 90, and that should, in fact, give us the freaking height of the Holy Temple.
Yeah, the freaking height.
Cancel. I was wondering, how does it feel?
Look at that.
How does it feel?
Don't say the answer out loud because I want to do it too.
Okay.
Taylor's been nice and quiet this whole time. He probably knows exactly how to do it, and he's just letting us struggle.
He's probably getting like insiders from his daughter.
I know, for real.
That makes sense. Yeah. 168 feet. Okay. That's not loud. Okay, I'm going to type it in white so you can't see it, but it's going to be there.
Ooh, mysterious.
And yeah, about trying to look up the answer. This answer would make no sense logically, but it does in the context of the problem.
Is there any homework problems that are like this that we have to do this week?
Yeah.
Because we could probably look up on how they did it there.
No, this answer makes sense. Okay, here's the thing. My dad has this friend that he used to work with at Boeing, who knows how many years ago.
At Boeing?
At Boeing, yeah. And this guy's a whiz at math, and he's been helping me to do stuff like this. This is how I know how to do stuff like this. He told me how to do it. So.
I wish I had a friend at Boeing.
No kidding.
I wish I had a friend.
How did you go from what you had to what you had below that?
What do you mean?
So it's just sine of 36.5 times. I don't get why you were able to switch out the dividing and stuff like that.
I don't get it either. I would think that you would multiply this 36.5 by this division.
Yeah.
But he explained to me to not do that. He's like, don't do it that way. Do it this way, and it will work every time. Don't ask me how, but it works.
Did he say don't ask him how?
No, he didn't say don't ask. It's cross multiplication.
No.
It's cross multiplication.
Don't say anything to anybody.
Where's the divided by some? There it is. Did you get 168.66?
Mm-hmm. Which, again, would make no sense because there's... does that make sense? Could a temple be that high? Let me look at that up. Does that make sense logically in the real world? Watch it actually be true, and we could have looked it up from the beginning. How tall is the Space Needle? No.
Well, let's go measure the Space Needle.
It makes sense. It makes sense.
Yeah, I mean, in the context, that makes sense.
Well, no, I mean, like, the equation makes sense because
I
don't know, but I don't know why. It just does. Don't ask me. It just makes sense.
Guess what? The height of the temple is drum roll. 169 feet.
Nice.
We could have looked it up in the first place, and we would have been close.
I think I said that.
All right, was that the last one?
That is, in fact, the last one.
Yeah. All right, this might be the highest quiz grade that we get in a while, guys. I feel good about this one.
Problem is, here's the thing. Here's my problem. We literally only have 2 questions, and so we miss one.
3.
Boom, 50%.
We have 3. We have this expression.
Sorry.
You got the first one right. I know that.
And we got this one right. I felt good about this one. I mean, we looked it up online. I mean, come on. How bad could
We
it
at
be?
least got a 66.
Yeah.
Okie dokie. Okay.
Are we out? Are we done?
I say we're done.
All right, I gotta go pee really bad.
Okay. Take a pee.
All right, I'm not gonna take it. I'm gonna leave it.
Take it or leave it.
All right, see you guys.
See ya.
Bye.